Alright, welcome to the first lecture of Cubstart iOS. So just to confirm, this is the iOS track of the Cubstart decal. We have two tracks. We have the web track and we have the iOS track. So everyone here is in the right track. Good. Good. Nice. All right, so welcome to lecture one. I know it's a rainy day. Hopefully you're staying dry. Without further ado, let's get started. So today we're going to be talking about motivation, Git, and we're going to jump in with the first taste of what Swift is. So today's agenda, we're going to go through introductions. Then we're going to start off by talking about why OS, right? Why are you here? Why is this important? And what can you take out of this, right? Next, we're going to talk about course logistics. Then we're going to talk about Git and how, again, hopefully you have some experience with Git already, but if you haven't, no worries. And then we're going to actually take our first look into iOS development with Swift. Okay, and then we're going to end with a quick conclusion. So announcements. So make sure you're on Ed. So there's the Ed link right there. If you haven't, again, these slides are posted on the website, which is www.cubstart.com. If you aren't enrolled in Gradescope, please do by joining our Gradescope class using this code right here. And please do this ASAP, as the homework that will soon release shortly, you'll be turning it in Gradescope. Homework one will be released very soon, again, and it's due next Friday, Valentine's Day at midnight. It's not too long, but I recommend if you haven't programmed before or you have some little programming experience to start early. And we're really active on Ed, so please utilize Ed as much as you can. And we also have office hours in which I'll talk in a minute. Cool. And if you have any feedback, there is a section on the attendance form where you could add feedback for today, what can we improve for each lecture, and so forth. Alrighty, so who are we? So I'm Justin right here. I am a junior EECS, and yeah, I've been teaching this decal since fall of 2023, so quite a while. And we also have my co-instructor, Dylan.
Dylan. Teach this decal since last fall, so I'm happy to do another semester of this course.
Yeah, awesome. And we also have a TA team. You should probably see them in the following weeks, but yeah. Alrighty, let's get into logistics. So this is our curriculum. This is our first lecture. And then as you see, we're going to go into more and more about how to build UI, kind of different frameworks of moving data around. How do we use data? How do we make our app more expressive with animations? How do we contain data persistently with Swift data and Firebase as an alternative? So you're going to be learning different, wide variety of tools to make you a proficient iOS developer. And so iOS, development touches on a lot of different details. So it's really, really cool to see how everything kind of fits together at the end. So here are logistics, our course website. This is not the decal website. This is our own custom website. Again, it's at www.cubstart.com. It has the schedule, lecture slides, recordings, and the homeworks. So it has everything that you need. Homework, we have one homework. It's called homework one, and it's due next Friday. But we also have mini projects, and these mini projects will span across 2.5 weeks or so. And each of those mini projects, they have a weekly checkpoint. Now, they're not due. There's nothing to turn in at that weekly checkpoint, but that's just a guide so that you're on right track. So if you're able to hit that weekly checkpoint on that week, you're on the right path and pace. Now, we currently have planned for 2 mini projects, but maybe 3, but most likely 2. And again, weekly checkpoints. And for discussions in OH, discussions are also mandatory like lectures. So we will be keeping track of attendance for both lectures and discussions. So yeah. So for homeworks and the mini projects, we won't be giving extensions like we did before. This semester, we'll try something new. We're going to have 10 slip days for the whole semester. So 10 days of extra days. It's quite generous, as again, the homework and mini projects aren't like we allocated time so that you're able to do them within the amount of time that we have. So use them sparingly. And they're non-negotiable, so no extensions. So please use those slip days only if you have any extenuating circumstances or some serious issues that arise. So yeah. But if you do have DSP accommodations, extensions are permitted. So if you used up all the slip days and you need some more extra time, just please create a private ed post. Assignments will be released on a Tuesday schedule and will be due on a Friday schedule. All right, so discussions know which. So they will be Thursdays 5 to 6 at Soda 306, which is HB Auditorium. Discussions, this is mandatory. It's 1 hour long, 5 to 6, and it will be review of lecture topics, or sometimes we'll be expanding upon them, right? There's so much stuff that we could get into lecture, and some of the cool stuff we want to really talk about, we just can't. So we're going to dedicate some of the time in discussions. We have prepared discussion worksheets. So if you have taken a prior CS class at Berkeley, it's sort of the similar thing where you have those discussion worksheets. But sometimes some topics, it might be better to have more of live hands-on activity. But that's at the discretion of the person who is doing those discussions. And then for the other hour, 6 to 7, it is OH. It's optional. If it's a work session, so if you want to, quickly hammer out a homework or mini project, or have any questions, this is a great time to do so. And, if you want to meet other people and talk about, different kind of things, this is a great opportunity to do so. Okay. All right, attendance and requirements. You're allowed a maximum of 2 absences for both lectures and discussions, so 4 total. If you used up those 2 absences, for example, let's say I've already used up my 2 absences for lecture, you can fill out the excused absences form on Ed if you have used up your 2 respective absences for either lectures or discussions. Please do not email us for excused absences, so please use that form. We won't be accepting time conflicts as we really want to have in-person attendance. So if you have time conflict, that would be a bit difficult because lectures and discussions are mandatory. And we will not be accepting submissions to the attendance form after 6:15 p.m. So after 15 minutes has been passed, after lecture or discussion has ended, we will not be accepting those submissions. Absences beyond the limit of what's being described here will be automatic result in a grade of no pass. And you need a computer with macOS to take this course. Specifically, macOS Ventura 13.5 and Xcode 15. And if you don't have the requirements, please let us know ASAP so we could figure out something for you. Now, the main part of this, or at the end, the main kind of cool thing about Cubstart is there's a final project and demo day in which you would design and build an app in groups of 4 of your choice. More information or requirements will be released later this semester, in which you'll create slides and live demo. It'll be sort of like a science fair style. So you kind of meander around and you get to see what other people have built. And you have a total around a month to work on it start to finish. So plenty of time. And demo day is a 2-hour event during our week, in which we basically have that event. And there's going to be prizes for certain categories. For example, last semester we did best UI, best community impact, and etc. Absences without notifying us at demo day will also result in a no pass. We have a few people that did not. Again, we have repeatedly asked, hey, if you couldn't make it, please let us know. Here's a form you could fill out, but they didn't. And unfortunately, we have several students who had an automatic NP because of that. All right, so these are some of the demo days that we did in the past. This group right here did a really cool kind of journaling app where basically you have to keep on typing, but if you pause for like 10 seconds, it'll basically delete what you did. So you had to keep on typing as to, like a free form or free prose kind of thing. The student did a really cool game where you have like a recursion tic-tac-toe where you have to solve a tic-tac-toe game in that square and to get that X or circle for that kind of square, which is really cool. This group right here did like a coffee kind of app, or you could explore different kind of like stores around Berkeley. And here is the group with Dylan, where they built like kind of a really cool bookkeeping or reading app, and you could keep track of your quotes and things like that. And they use Firebase as well so that it's synced with multiple devices too. Okay, so these are some examples that the demo day kind of apps that students did. So hopefully this gives you some inspiration. Um, and yeah. All right. Any questions so far about the kind of course logistics and stuff like that? Are we pretty clear? Good. So, before we kind of jump into Swift and the more technical stuff, I like to kind of dedicate this time to kind of talk about iOS, right? Why is this? Why did you take web? Why is iOS even important? Well, it's apps, 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 right? It's everywhere, right? From basically using to watch YouTube, from media, entertainment, to productivity apps, to more kind of for games even, right? So it's part of our daily lives, and it's more and more increasingly connected to, in which I will say is like it's an extension of ourselves, right? If you want to, I guess, communicate with someone, we reach for a text or we reach for FaceTime. And so these apps kind of unlock new experiences or new portals um, for users to kind of, integrate within society itself. So being able to kind of tap into this field, I think is really powerful and really cool. And the main reason for this is I think the idea to reality kind of aspect of iOS development is really cool. So usually you have a problem, right? You're trying to, you're stuck on this problem or have a daily nuisance in your life and you're like, oh, I wish I could solve this, right? And then you have kind of idea of like how to solve it, right? You might say, I create a website for it, but kind of maybe that's not what I'm looking for. But maybe, hey, maybe a mobile app is one of the probable solution to this problem. And that, leads you to code your app. The process of kind of tinkering around, figuring out what UI looks the best or tapping what features on the phone that you could use. Maybe you want to use a camera, a microphone, and things like that to make it to accept more modes of communication or media. And then once figure out your app, you think it's ready, it's polished, you can just publish to App Store to ship it to everyone around the world. And, if you're more on the entrepreneur side, you could also tag along a price tag to it so you could earn some cash in the meantime. So again, this is a pretty cool kind of pipeline. So once you have that problem, once you solve it to the very end, I think it's very rewarding, gratifying. Since you can just pull up on your phone, you're like, damn, this is really cool. So yeah, hopefully by the end of the semester or even in the middle semester, you get to kind of experience this kind of um, pipeline. All right. And again, why is this so special? On the design side, we have, iOS development touches on a lot of different things. You have to be aware of the UI UX paradigms, right? Interactability, what kind of graphics, rich graphics. Also, sometimes, you need to think about accessibility for people who might have motor disabilities or vocal disabilities. And so Apple provides a lot of APIs to do with that. So you have this kind of creative aspect of iOS development. And also, you also have the CS part, right? You got your programming language, you got your algorithms, you got your design paradigms of how to structure app architecture, and you have a lot of frameworks for UI and tapping into different services that Apple have. And in the middle of that sweet spot is iOS development. And I think that kind of intersection between design and computer science is what makes iOS development really special. Um, and it kind of gives you a really well-rounded, uh, it makes you really well-rounded developer since you're touching a lot of different things. So what can you do, right? The answer is a lot. So these are some of like my favorite apps. I use Things 3 every day. I'm not sure if you guys have heard of this, but it's a really well-made, simple to-do list app that I rely on every day. I don't know if you guys use Flighty for apps. Again, this is a native app. It's beautiful. You can basically enter your flight number. It shows you kind of your journey, and also it shows you more information about the airplane, your seat number, yada yada yada. And this is a little project that I've worked on. It's just a game. It's a Cantonese style card game. It's called Big Two. And you can build something with this with Game Center. So there's a lot of possibilities of what you could do, and it's unlimited, right? The only restriction is your creativity. And so this is, your phone is an empty canvas, and whatever you want to imagine or put on there, it's up to your discretion. All right, let's talk about how do we build iOS apps. So this is the current mobile tech stack landscape that we have right now. So one kind of category is called native apps. So this is all the tools made by Apple. It's first party, so it's only used for Apple platforms. And the second category is what we call cross-platform frameworks. So it's you might have heard of React Native from Facebook, Flutter from Google, Ionic from I don't know. But these frameworks you can target both iOS and Android with a single code base. Um, but in this decal, we're going to use native. And why native? Well, it's because we can adopt the latest frameworks and tools that Apple has released each year, in which I'll kind of give you a better diagram of what that means. If Apple wants to change something, for example, some UI elements or system UI elements, your app, if you build your app with native tools, you get them automatically for free. Usually you get better performance. So since all these frameworks are, again, built, maintained by Apple, they are optimized for Apple Silicon, for your phones, your Macs, and all of their chips. And also, if you want to tap into hardware, for example, you want to get access to a camera, you want to get access to the photos, the user photo library, you want to get access to the user calendar, if you want to get access to the microphone, Bluetooth, things like that, it's much more easier to do that with a native app than a cross-platform app. All right, so this is how Apple releases their operating systems. So currently, again, we're in this kind of phase. Right now, we're still in iOS 18.3 point something. Um, but in the middle to late of June is WWDC, which stands for Worldwide Developer Conference, and that is the event where Apple releases their new OSs from iOS, macOS, watchOS, tvOS, and visionOS. And they release also for developers APIs or basically new code that can harness new abilities for us. And so between that to mid of July, this is Apple releases a developer beta. So what that means is that if you're a developer or registered developer, you can get access to their newest OSs and basically try to compile your app or to those new OSs. And then from mid-July to mid-September is the public beta in which everyone else can try to, if you want to try their new OSs, report bugs, you can. And then here is where in mid-September is where they actually release the new operating systems for iOS. macOS is usually a bit later in October, but you get the point. And so here is also where you get access to publicly the new versions of Apple's development kit SDKs and tools. Okay, so that is kind of a time frame of how Apple releases their OSs and tools. And if you're a seasoned iOS developer, you'll call WWDC as Dub Dub. So if you, next time you meet another fellow iOS developer and say, hey, when you do want to watch Dub Dub together, to be like, wow, you know the lingo. So that's something cool. All right, let's talk about how to build native iOS apps. The first component is Xcode. So Xcode is what we call an IDE, which is called a shorthand for Integrated Developer Environment. So this is like PyCharm, this is like IntelliJ if you've done 61B before. This is where you will code and live for this semester. There's a lot of features packed within Xcode, which includes debugging support, SwiftUI previews, and we'll talk about that next lecture. And the APIs for now, you can think of it as like the code, some code that is tied to the OS version. So iOS 18 has some APIs or code that you can only do within iOS 18, right? And you can only use those new APIs with the newest version of Xcode. Again, you need to have Xcode 15.0 or above, and you could download Xcode via the Mac App Store. And you need macOS Ventura 13.5 to do that. So again, if you don't have those requirements, please come after a lecture to talk with Dylan or I about this. The next component is Swift. What is Swift? Swift is the programming language, all right? That's how you write code to perform computations, different algorithms. You structure your logic and data models. It's not like Python. It's similar to that. For those who have taken 162, it's also brings elements of Rust into it. So you have done Rust, you might be familiar with some ideas with it. And also has some helpful, unique features that others really don't have. And it's very beautiful, I gotta say. It's I think, one of the most beautiful languages written. But again, it's subjective, but I swear, once you use Swift, you'd be like, wow, that is really beautiful. Okay, so trust me on that. The third component is SwiftUI. right? So Swift UI is a UI framework. That's how we build UI views, right? A button, an image, text. And you can, it's a declarative framework, which means that you simply state what your UI should do. And it's very simple. So let's say, I want to build a more complex view. I could basically aggregate more different views together to create more complex view. Okay. And it's cross-platform. So what that means is that you could have a single code base that targets all of Apple's 5 currently supported platforms. So it's really cool. Okay. And for example, let's say I have my code base, I build an iOS app. If I want my app to be on Vision OS, I can just add some tweaks to it so that it looks great and works really well with Vision OS. So we used the programming language Swift to write code to control Swift UI. And we'll see what that means in next lecture. So we also can extend functionality with frameworks. So Apple provides a bunch of frameworks for developers to extend functionality of their applications. If you want an Apple Maps view, use MapKit. If you want to show tips to allow for user discoverability, use TipKit. If you want to save persistent data, so when the next time the user quits their app, they can, next time they load their app back in, they could still see the data there, use Swift data. If you want to extend your app's capabilities via a widget, use WidgetKit. If you want to recognize speech to text, use speech. If you want to train a ML model, use Core ML. And so there's a lot of these tools that you could use. So again, the limits of what you can do is your own creativity. So again, it provides you a bunch of technology and tools to do exactly what you want. And again, I'm just scratching the surface. There's like 100 of these frameworks that you could use. So again, it's really cool. Any questions there? Hopefully you guys are motivated now. Hopefully you're like, yes, iOS. Okay. All right, let's talk about Git now. So Git, again, hopefully, how many guys have used Git before? You know what Git? Okay, good. If you don't know what Git is, that's okay. We're gonna go through it. So Git is an open source version control system that allows you to save your code locally so that you can return to previous versions if needed, right? GitHub is another service. This is a cloud-based hosting platform for your code that allows you to share and access your code with other people. So this is how you will collaborate with your partners on the final project using Git locally and GitHub as a service. On GitHub, you might see the term repository. That means it's synonymous to project. And these two kind of work in tandem with each other. So let's see how they work together. So let's say this is person A right here, and this is person 2, right? On both of their computers locally, they will have something called a local repository. So the project, again, the code is on those two persons' devices. Now, person A, wrote some code, and he wants to have the code reflected on her computer. So what person A can do is do a command called git push. And again, I'm simplifying things here, but I'll talk about kind of the more commands of what it means. But git push is one of the final commands in which it basically pushes the changes on person one's local computer to a remote repository. And then in which person 2 can do git clone to get those changes. Or once it's already been established, the repo has already been established, they can do git pull. So git clone is only when person 2 doesn't have it locally already, but once she already has it locally, she could do git pull. And the remote repository is what we call GitHub. Okay, this is like Google Drive. This is the cloud. Okay. So let's talk about more in detail about Git stages. So these are kind of the stages that your code or your projects are going to be in. So you're going to have your workspace, which is your code. The first command is git add, and that adds your current changes or files that you have modified to something called the staging area. And this is just like putting aside those files that you have been modified. Okay, so you're putting aside those files that have been modified. The next step is to do git commit with a message, and that basically takes a snapshot. So it's like you put your files that have been modified to a side, and you're like, okay, I'm gonna take a photo of those changes. And then you do git push so that you basically take that photo that taken and you upload it to GitHub so that it's on the cloud. And then the other person can now basically get pull to pull down those changes that person one has done so that the other person, person two, can to be in sync with each other. Okay, so those are the four main commands that you'll be using. And it's okay if you're not familiar with this, you'll be much more familiar with the as the semester goes on. So Git and Git Xcode. So Xcode includes name and address as the author and source control history. So once you have Xcode downloaded, you will need to connect your Git with Xcode. So, hopefully it should, I'm not quite sure if it's already done automatically, but if it doesn't, you just put your author name, your author email, and things like that. So it should be there by default if you have Git installed already. Um, so if you want to use GitHub within Xcode or Git within Xcode, you could do so. There's a UI to do that. To do that, you just sign into GitHub. And since GitHub requires authentication now, you need to create a token and enter it into Xcode here. So you can do that via Xcode preferences account. If you don't know how to create a token, you can just search it up on Google. It's pretty straightforward. Okay. All right. Any questions there? All right. All right, now let's get into some Swift fundamentals. This is your first look into Swift and iOS development. So again, I'm going to start from the very beginning. So again, if you have programming experience, this should be familiar. And so if you do have programming experience, I suggest you to look at the differences and compare and contrast with another language that you normally use. For example, if you use Python, try to look at similarities or differences between Swift and Python, right? And etc. And for those who have no programming experience, again, this might be a bit fast, but if you do need help, there's a plenty of resources which I'll link on the ed so that you can be up to speed. Okay. All right. So data types. When we program, there's a lot of, we're always going to be working with some data around, either manipulating data or handling data here to there. So here in Swift, we have these 1, 2, 3, 4, 5, 6 kind of primitive data types, kind of the main fundamental data types that we have. First is integers, floats, which is basically decimals. Doubles are also like floats, which are decimals, but they have more precision. So they're more accurate in a sense. Booleans have a true or false value. Characters are basically like a character within a string. A string is a sequence of characters. So here you can see this is how we kind of represent these data types. So we do var age, colon, integer equals 19. So we're basically saying we're assigning the value 19 to this variable called age, which is of type integer, and so forth. So you can see, again, this is should be pretty familiar. And again, in Swift, a float has fewer places of precision than a double. Don't worry if this means nothing to you. If you have taken 61C, this should be familiar. What this means is that just use double, don't use a float. All right, so how do we declare a variable? So it's here we use the var keyword, and here is the variable name, followed by a colon of the data type and an equal to the value that you want to assign. So what this is saying is that it's assigning the integer value 19 to the variable called age, which is a type integer. All right. So what we could do is that we could do something like this. So this is, again, from the last slide. Here we're doing age equals age plus 1. What this is not saying is we're saying is age, the same value as age plus 1. This is not what we're saying. Again, a single equal sign means assignment. So what we're saying here is that we want to compute the value on the right-hand side first. So we're saying 19 plus 1, which is 20. And we're assigning that new value back to age. So we're adding 1 to age and then assigning the new value back to age. So age is now 20, like so. And so when we print it out in the console, we should see 20. Okay. Now, there are two types of variables. One is mutable variables, and the other is immutable variables. So immutable variables are exactly what they sound. Once you have initialized the variable, or once you have assigned a value to that variable, it cannot be changed. So we basically changed the var to a let keyword, and that makes age immutable. So when we do something like this, so again, same code, but we just changed the var to a let. Xcode is going to yell at us saying, "Hey, you cannot assign the new value to age because age is a let constant." And you might be saying, "Oh well, Justin, why would you want to use let, right? Shouldn't we just use var since it's just much more powerful. We can manipulate it." Well, sometimes there's variables that we use in code, such as that we call magic numbers. For example, pi. We don't want to change or some user to change the value pi. So if you want to have those constants, it's better to have them as let than var. Now, Swift is powerful enough, it's smart enough. And so there's a thing called type inference. What that means is that, again, this is the same code that we had before. We could drop the colon integer. So we don't need to explicitly say, hey, age is an integer. Why? Well, since we're assigning the value of 19 to age, 19 is an integer. So Swift is able to infer that age is an integer. Tuples. Now, this is similar to Python. Tuples are a comma-separated list of types enclosed in parentheses. You can name the elements of a tuple and use them to refer to the elements. So, for example, in mathematics, we want to kind of represent coordinates, right? And this is a 2D system. So we have coordinate, and it's represented as a tuple with two elements, right? We have x and y. And each x and y is assigned a value to them, which is both 10 currently. And so if we want to print out the values or kind of enclosed within this tuple, I could use coordinate dot x using dot notation, referring to these labels right here. So coordinate at y as well. Or I could use numbers. So I could use coordinate dot 0 to refer to the first one and coordinate dot 1 to refer to the second one. If you have more elements, it will work the same way. So coordinate dot 2, dot 3, and so forth. So it's just a collection of items in a really light form way. Collection types. So in Swift, we have these different data types that conform to a collection. And collection itself, if you have taken 61B, it is a interface in Java. And in Swift, we call it as a protocol. So in the three main collection types in Swift are arrays, sets, and dictionaries. Arrays basically is a collection of items, an unordered list of items, and the elements within those arrays can be accessed via their indices. A set is an array is a ordered list of collections. My bad. A set is a unordered list of collections, and in which, but set differs from array because it has additional requirement where a set, all of the items within a set must be unique. Okay, so you can't have duplicates within a set, but you can have duplicates within an array. And a dictionary is sort of like what a real life dictionary is. You have a key and a value pair. So for example, a word has a definition. So you can access a value via its key. So let's take a look at an array. Again, it's an ordered list. So the elements within an array have an inherent ordering. So again, another requirement is that elements in an array have to be the same type. So you can't have an integer here. Okay, they all have to be strings in this case. Now, how do we access elements? We can access these elements via indices. So for example, when we do birds, open bracket, 0, close bracket, what we're doing is that we're getting sparrow. And the reason for this is because each element has assigned or associated index. And Swift is 0 indexed. So to get the first element, you do 0. And to get hawk, you get the index 2. Now, unlike Python, Swift does not support negative indices. So you can't do birds -1 to get hawk. Some array operations, the first one is called append. Append simply adds the new element at the end of the array. So when we do birds.append owl, it basically birds is now changed. So now the value has owl at the end of it. Now let's say we want to append a list or an array. We could use another version of append called contents of, and which would pass in the array. So again, same thing with the append, but append only appends one element, where with this version of append, we could append an array to an array. So here we can see now we have hawk owl because of here. Okay. Now, what if we want to remove an element? We could do simply by giving it an index. So here, again, this is 0, 1. When we do remove at 1, we remove eagle. So now it's just sparrow and hawk. Control flow. So this right here is how you do if statements in Swift. Sort of like Python, but again, with the main difference between Python is that Swift used brackets instead of indentation and colons. So here we have two variables, which is age and name. Age is set to 50, name is set to Joshua. And how this works is that we basically go down all of these different clauses. So let's check. So we go down to here. This is the condition. So is the age less than or equal to 1? Not so. It is not, this is not correct, right? So we go down to the next case or condition here. Is age less than or equal to 4? Not quite. So we keep on going down, right? Is age less than or equal to 17? Not so quick. Sorry, these should be updated to, these are not toddlers, but you get the point. Once we get to, okay, so once all of these cases have been exhausted, we go down to the else case here, and this is kind of our fallback. So if none of these conditions are true, we say, we execute what's down within here. Now, what makes Swift really cool is that there's a feature called string interpolation. What that means is that you can embed a variable into a string like this. So you could use this, I don't know if this is backslash or slash, but you get the point. You get the slash, and in parentheses, you give it the variable, and it will basically put it within the string, which is really cool. So you don't need to use concatenation of pluses and making sure your spaces are all right, or percent formatters with printf. You don't need to worry about any of that. So this is a really cool debugging power tool. And so at the end, it will print the last one. Loops. So for loop. For loop, there are two main ones. One of them are called half open ranges with the dot period less than or equal. So what this means is that the first number is included within this range, and the second number is excluded within this range. The second range is called a closed range, which the first and second number are both inclusive. You can think of this as in math with intervals. So to represent an interval where the number is inclusive, we use a bracket. And when the other number or in the number that is excluded in the interval, we use a parenthesis. So this is sort of the same idea here. Now, to use a for loop, we use this kind of syntax. This is pretty similar to Python. We use for, and then here we basically, after the in, we have this kind of range, okay? And then here, after the for and before the in is our variable. So what this is doing is that it's going to start at 0, and then it's assigning to I, wherein we're printing that I out. So we get 0, and then we go to the next one, 1, 2, 3, 4. Now, the reason why this is 4, not 5, is because, again, this is a half open range where the last number here is excluded within the interval. Now, we could also use for loops on a collection. So, for example, we could use the same syntax for name in names, in which we're basically we're starting at the first element, we're assigning that to this local variable name, and we're printing it out. So this is another way you could use the for loop. And here's the same thing, but using on a string. Now, the letter here, this is not a string type. This is actually a type character, because in Swift, a string is comprised of characters. While loops, pretty straightforward. A while loop is kind of analogous to a for loop, but the main difference is that it basically repeats the code within these brackets indefinitely until this condition is not true. So at first count is 0, 0 is less than 0. So this is true. So then we do this, and then we increment count by 1. So it goes to back to here, is 1 less than 0? True. And then it continues onwards until count is false. So while the condition is true, we repeat, else we stop. All right. Now, for those who haven't been paying attention, this is time to wake up, because this is how Swift does functions, and it's very different than what other programming languages do. So to declare a function, and a function is basically an encapsulation of a section of code that you could basically reuse multiple times. So here, to declare a function, we use the func keyword followed by the function name. And then here we have the parameter name, the name, or I guess the variable that it accepts, right? And then we basically specify the type of that parameter. And then to basically call at the call site, we basically use the function name, and then we basically use the parameter name, and then we pass in the data that we want to pass into the function, and that is an argument, 1 and 2. Now here you could see this is a function called greet. It has two parameters, right? We have person and we have hometown. Now, you might see here, is this a typo, right? Why do we have two parameter names here? We have from and hometown, right? Now, the main reason for this is because Swift, you could also include something called an argument label. Now, if you elect to do that, the first parameter, the first kind of label here is called the argument label. And this is used when you call the function. So this right here, this label here is used at the call site. The next one, the next label is the actual parameter name. And this is used within the function implementation. And to specify the return type of their function, functions can return, in which what that means is that a function can regurgitate some value out, in which you can assign that value back to a variable somewhere else. So here we're basically saying that the function returns or regurgitates a type string. So when at the call site, right, you can see that we're basically calling greet. Since this parameter only has one label, we just use that as a parameter name, and we're passing the argument Tim into it. Here at the call site, we're going to use from because that is the argument label. Okay, we're not going to use hometown. We only use hometown to reference this parameter within the function implementation here. Now, the reason why Swift does this is because it makes you to write code that reads like English. For example, greet person Tim from Cupertino, right? And then here we have the string that we're returning, in which basically string interpolating this person, which is now, hello, Tim, glad you could visit from Cupertino, right? If we only had one right here, sometimes, at the call site, it's kind of fugly, it's kind of ugly, right? So now with this tool, you could write functions and write, function call sites really beautifully. And so it reads like English. Does this make sense? Yes, question.
You have to write like the first parameter name, like
Yes, you do need to do. But there's an exception where you could omit it, in which I can talk it in the next slide. Okay, good question. So here is exactly what you asked. You can omit the parameter name at the call site with by substituting the argument label with an underscore. So what we're saying here is that now this function, at the call site, you don't need to use the parameter name here. Okay, so since we have that underscore for those both argument labels, here when we call add two nums, we don't need to use a colon b colon. Okay. And then here also, you can see that we have this equals 0 for both of these parameters. What this means is that now these parameters have a default value. So if we look at here, if we do add two nums 8, this corresponds to this parameter right here. But since we're omitting the second parameter, it defaults to 0. So what we're doing here is we're doing 8 plus 0. Cool. Enums, so enumerations, what are they? Enumerations declare a common type for a group of related values. So they're usually for constructs that can be represented by a list of cases. So for example, let's say we want to represent the state of matter. How do we do that? Well, we could do that by listing 4 variables, but that's kind of difficult to kind of categorize and kind of, keep track of. So what we could do is that we can encapsulate those kind of cases via an enum. And so a enum here, we declare an enum called matter state, and we basically list or enumerate those cases within matter state. And here we have another example called direction, right? We're encapsulating these list cases into a single data type that we call direction via an enumeration. And again, we'll see an example how to use enums later on. If you used, I don't know if Java has switch statements, but if you used C, for example, there is a switch statement. So what a switch statement is that it considers a value and compares against several possible matching patterns. If match, it automatically jumps to the correct condition and executes the appropriate block of code. And it provides an alternative to the if statement if you're handling multiple potential states. The one condition of the switch statement is that it must be exhaustive. So you must provide all possible cases of the value that you're trying to compare with. So for example, here on the top, we're initializing a variable called current direction, which is of the enum that I've declared in the prior 2 slides. So what we're doing here is that we're on the right hand side, we use dot left. You could also use direction dot left, but since I declared the data type here, I could just use dot left as a simplified way. Okay. Now we're switching upon this current direction. Again, it must be exhaustive. So I have to list all possible conditions of what current direction must be. So in the top two cases, I basically state the case of left, right. And if, in this case, since it's left, it jumps directly to here and it prints out turning left. If it was right, it automatically jumps to right without having ever to go to left and then right. Now, I don't have up or down. And the reason because this is that because I have this default keyword, basically it's sort of like the else clause of an if statement. So if none of these matches, it just directly goes into this default case. Make sense? Cool. All right. I'm really pressed on time. So I prepared a quick demo of kind of utilizing what we learned uh, in Swift. So here is, again, this is sort of the, I guess, this is what Xcode will looks like. But we don't worry about Xcode for now, but let's just look at this problem that we have here, okay? So this problem is called mosaic and returns true or false if the tile grid is a mosaic. Each of the row of the tile may have a different column count. So if you think about this in a 2D kind of array, a tile grid is considered a mosaic if all of the tiles are recognized mosaic tiles and if there are specified numbers of tiles left untiled. And an untiled is represented by an empty string. So again, we have here the first parameter, tiles, which is a 2D array. And what that means is that it's an array and each of its elements are also arrays. These are an array of recognized tiles, and we have an empty count specified here. Now, because I'm pressed on time, I'm just going to walk you through it. Okay. So the first step is to kind of basically get everything that we have so far. Okay. So what we're going to do here is that we're going to create a new variable called numRows, and also, if you might notice, Swift conforms to is this camel case? I forgot. Is this camel case? I forgot what it's called. This is okay, camel case. So it's not like in C where you have to separate each kind of main syllable with the underscore. So we use this kind of camel case syntax for writing variables. Okay, so we use so the number of rows in my grid is done via tiles.count. And now I'm going to create a set of my recognized tiles because here there might be duplicates and we don't want duplicates. And another reason why we want to use sets is because the reason why we want to use sets is because it's unique and we could do comparing operations really quickly. If you're taking 61B, you might know the reason why is because sets are hashed, elements are hashed. And so you're able to get those or compare elements, for example, like contains in O of one time. But that's out of scope for this course. Um, is this exactly what I want? Uh, let's just don't worry about that. So we want to loop through all of our tiles within here. And to do that, I could basically write a double for loop. So the first for loop, I'll basically loop over the number of rows. So to do this, I basically create a variable I, and I just use 0 dot dot use the half open range, right? And this basically loops over 0 to num rows. And then for the second for loop, I loop over the columns. And because of this condition that the grid may have different column count, I have to index into that row and get its count because that mosaic could be different. Kind of, it's not a symmetric grid. And then to get each tile as a character, I can use tiles dot I, and then by this to index into a specific element in that 2D array. And then also, another pro tip, if you do option click, you could also see the type of it using this popover. So you can inspect functions, you can inspect variables via option click. And then here, I basically say if the tile is an empty tile, what I want to do is that I want to increase my empty tiles counts property to 1, and I could basically create that right here, empty tiles count, and set that to be 0. And then else if right here, what I could do is that I can now see if that's if the set here contains that tile. And if it's not, if it does not contain, I immediately exit because we know that, to make for this tile grid to be valid, it must contain within this recognized tiles, right? Um, Tile here. And then here at the very end, instead of returning false, I basically say empty tiles count equals empty count, empty num. So because again, this is used at the call site, this is used within the function. So yeah, that is again, sorry if I ran through this really quickly, but the code is also linked in the slides. And let me just quickly go over the conclusion. So yeah, this is the lecture for today. Hopefully you have a better understanding of what iOS development is. Hopefully you are excited about this decal. You're gonna learn a lot. You know how to use Git within your workflow. You know Xcode, Swift, SwiftUI, what those terms mean. And you know a bunch of some Swift fundamentals already. So you're really off to a good start. So